Hello and welcome back again. Today's video, I will have to start with a parental advisory for explicit lyrics. That is because I will probably be using the word ass a lot. This is because I believe that 95% of the explanation of Galileo's historical significance was the extent to which he was a historic level ass. And so I've tried to figure out how I could say that more kindly, but I think this really gets the idea across, and this is what I'm going with. So if you're an ass, you can use this video to figure out how you can leverage your particular strengths to get into the history books. If you know someone who's an ass, you can direct them to this video and tell them how it is a celebration of the achievements of their people. Either way, you've been warned. All right, now, when we left off in the 1500s, we saw several areas of tension. One was between the academy, the universities at the time, and the papacy, about who really had the authority to comment on scripture and philosophy, and the other was between that university system and people out in general who just had more access now to Greek works and philosophy and wanted to read and analyze it themselves without a PhD. And it sort of threatened the university's institutional monopoly on that kind of activity. Those people who wanted to do this were called humanists, and this video is sort of describing the leading edge of what was called the humanist revolution. One such humanist scholar was a fellow by the name of Copernicus. Now, when fewer Greeks were known in Europe, then whatever, things seemed more uncontroversial. Whatever one Greek said about a topic, well, that's what was taken as truth. As more Greek works flooded in from Spain and from the Eastern Roman Empire, and people became exposed to and familiar with much more Greek writing, they saw more controversy, more diversity of opinion. And Copernicus was exposed to a lot of writings in which the sun was the center of the solar system. The Earth traveled around the sun. The current system of belief in the scholastic system was the Ptolemaic system, where the Earth was the center and the sun revolved around that. But Copernicus was exposed to much more Greek writing. He saw this diversity, and he decided to come down in favor of those that said that the Earth traveled around the sun. Now, what were the virtues? Why did he go with this? What were the virtues of that opinion? So imagine a mechanical model of the solar system in which we're going to hold the Earth still at the center of the universe. And now the sun revolves around the Earth, okay? And now all the planets are revolving around the sun as the sun's revolving around the Earth. The planets are traveling like this. It kind of reminds me of, there's a carnival ride where, like, in the center axle, there's 3 arms sticking out, and at each arm, there's 3 arms coming out of that. And at the end, there's a little cart that you sit in, and then these spin while the arms spin, and you're traveling like this. That was what the Ptolemaic system looked like, of the motion of the planets. And you had to use that to predict where planets would be at a given point in time. Now, the Copernican system, or the solar-centered system, the one that we're familiar with, is a lot more boring. It would not make as fun a carnival ride. You just have the sun there, and the planets just go around the sun like this. This made it simpler. It made it easier to do predictions. It made it more accurate. And these were really the virtues of the Copernican system. All right, now, the thing is, this, of course, contradicted the contemporary church teaching on the Earth-centered system. That goes back to Ptolemy and all of that. And Copernicus was not a scholar in the universities engaging in the scholastic debate, and so he didn't really have the authority to do that. He got his teachings banned. He always held on to him. He always believed him until the end. He got a book. He had a book published on him, and there's a story of he clutched the book as he was dying and such. But really, in general, he went gently into that good night. Now, about a generation later, Galileo made a much bigger historic splash when advocating Copernicus's system. Now, why would Galileo make a bigger splash advocating Copernicus's system than Copernicus made coming up with it and publishing it for the first time? And as I said at the beginning of this video, I believe the answer lies in the fact that to the extent of which Galileo was a historic level ass. Okay, what do I mean by this? Now, Galileo loved belittling and insulting people. Now, he was smart, and he could come up with great arguments and great debates, but his real passion lied in belittling people, it seems. For example, his friends told stories about how he would be saying something and his friend would agree with him and repeat what he just said. And then he would turn to that friend and say, "What, are you, an idiot?" And then argue from exactly the opposite point, condemning the friend for saying what Galileo himself had just said and insulting him and belittling him and all of that stuff. So this is what I'm taking as a characteristic of an ass. And we will see how that played a role in his establishment in history. All right, so now why do I say that this is what put him in the history books? Recall how I set things up. There were tensions between the universities and the humanists right now, of which Copernicus and Galileo were two. But there were also tensions between the universities and the Pope. At this point in time, this would be Pope Urban VIII, over who had authority to dictate on theology, matters of theology and philosophy, the educated university system or the uneducated Pope, who just happened to be the leader of the church. So when the university went to Pope Urban VIII and said, "Oh, you got to tell this Galileo guy to shut up. He has no right to be going around saying these things," this was a perfect opportunity for Pope Urban VIII to stick it in the eye of the universities. Also, it so happens that Pope Urban VIII and Galileo were longtime friends. So Galileo, stepping into this trial in which the judge of the trial was really at odds with the prosecutors and with the prosecutor's case and was good friends with the defense. Well, this was Galileo's trial to lose, and he did so spectacularly, because when he found out that the Pope was going to judge his trial, he just went off. He said that what I am saying is the truth, and no one can judge the truth, and anyone that tries to judge what I'm saying is stupid, is an idiot, and on and on. Now, that can cause some troubles. But then Galileo went a step forward, further. He published a book spelling out how Pope Urban VIII was corrupt and using the papacy to enrich his family's businesses. Now, in fairness to Galileo, that was all true. But after that, Pope Urban VIII couldn't really rule in favor of Galileo. So Galileo was condemned. His writings were banned. He was banned from publishing any further, and he was put under house arrest. But in this context, about a generation after Copernicus, there was much greater tension between the humanists and the university systems. And this act is kind of what lit the fuse that set off the bomb of the humanist revolution. Galileo was seen as a martyr for the, well, he wasn't killed. I don't know what you'd call it. You'd still call it a martyr if they weren't killed, but let's go with that. A martyr for the cause. And people would travel from all over Europe to visit Galileo in his house, to talk with him about these things. It really created a sort of a social revolution. And as I said in an earlier lecture, the real center of innovation and learning in Europe, in Western culture at the time, started to shift with this outside, from the university system to outside of the university system, people who were not university professors or PhDs. Now, let me take a moment here to play devil's advocate, because there were some problems at that point in time with what Galileo was saying. So what were the virtues of the Copernican system? Well, as I said earlier, the virtues were simplicity and accuracy, and those are great virtues. But what were the costs of the system? What do you have to give up if you're going to buy the Copernican system? And the answer at that time was pretty much everything else. The scholastics had a big system of what constituted rational inquiry and what physics were at the time and stuff. And the Copernican system contradicted all of that. So in order to buy it, you'd have to pretty much ditch what was considered all of learning at the time in order to accept this one fact. Let's take a look a little more deeply into that. So what were the physics you would lose if you bought the Copernican system? So Aristotle said everything was made out of a combination of four elements: earth, water, air, and fire. And that these elements had a natural place in the universe. Earth was in the center of it, water was the next layer, air was the next layer, and then fire was the outermost layer. And objects would tend to travel in straight lines towards their natural position. So for example, this pencil is made mostly of earth. If I were to hold it up in the air and then let go of it, it would travel in a straight line to its natural position until it hit the table. A fire, you light a fire and it travels upwards towards its natural position in the universe. So for example, in the last lecture, I said that if you wanted to explain why it rained, the answer God wills it was not considered good enough. Sure, God could create miracles, but usually doesn't. You had to come up with a better explanation. And that explanation would be in the context of this Aristotelian physics. Oh, also, that was terrestrial earth bodies. Celestial bodies like the sun and the moon and stuff, they were all made out of another material called, I think, aether. And that material's natural movement was in circles. So that's why the sun and the stars and everything rotated in circles in the sky, because of the materials they were made of. And obviously in this system, which was the basis for lots of their scientific explanations at the time, did not allow an Earth to revolve around the sun. It violated all of that. Secondly, let's take a look at the principles of rational inquiry. Way back when I was introducing Greek philosophy, I said that with Thales, what he really advocated was a sort of egalitarian view of knowledge, in which you take observations anyone can make and reason off of that in the steps of reasoning that anyone can follow to come up with knowledge. So, for example, there was an example with the cow. You come up with the conclusion that everything is made of the same substance because you watch a cow eat grass and give off milk. It's sort of egalitarian, anyone can do it. For example, an Aristotelian experiment, this is if you take a rock and you drop it, it hits the ground. If you hold it higher and drop it, it hits the ground harder. So the implication being that the longer the rock is falling, the faster it's traveling. So rocks accelerate as they fall. A simple experiment anyone can do, reasoning anyone can follow, simple conclusion. Now think for a minute how intuitively ridiculous the notion that the Earth rotates and travels around the sun can be. It's hard to think of this because we're so used to thinking. But step back for a minute and just look at the sun. I mean, does it feel like the Earth is rotating under your feet? Does it feel like the whole Earth is moving around the sun? There's a great line in Rosencrantz and Guildenstern Are Dead, where one of them, I don't remember which, takes a look and says, "Oh, look, the sun is rising," or "the Earth is lowering," as modern philosophy would have it. I mean, even if we would not deny that the Earth goes around the sun, still in our everyday talk, we talk about the sun rising. Contradicts this. So Copernicus's theory was based on observation, but what kinds of observations was it based on? It was based on data collected over the course of centuries, which needed to be understood by someone trained in the system. Suddenly, knowledge wasn't as egalitarian anymore. It wasn't based on simple observations. It could completely contradict some of the most compelling observations, like that the Earth is stationary. And it was based on more elaborate data that you needed training in order to be able to understand what it was saying. So the Copernican whole method kind of violated the principle of rational inquiry at the time. So all of that stuff would have to have been lost. Now, I said earlier that what was the saying of the rational man, or the reasonable man expects experiences to or circumstances to bend to. The reasonable man expects bends to the circumstances. The unreasonable man expects circumstances to bend to them, and therefore progress is made by the unreasonable man. And at the time, I think buying the Copernican system could be considered sort of scholarly dubious. However, as I said, there was this huge social movement going on and desire to get out from under the thumb of the authority of the university system. So a lot of people embraced it. However, that meant it was incumbent upon those people to address some of these problems I brought up. And this is what we're going to look at in the next lecture. Descartes took it on himself to just create a new philosophy, a new standard of rational inquiry. And Newton took up to create a physics which would support the Copernican system. So therefore, the progress was sort of made by unreasonable men, if you will. And this was the humanist revolution. Now, before we go, there's one more point I would like to make. And for that point, I'm going to take you back to the timeline. So let's go to that. Okay, so here's the timeline again that I showed you earlier, stretch of paper, and about here is where we've got Galileo and Copernicus at this area right here. And this is sort of the source of our modern perspectives of conflict between perspectives of science and religion, with all that we've talked about in this video so far. But I want to point out something. Notice that this is the whole history here, an 8 sheets of paper long history of human civilization. And our current perceptions of conflict between science and religion really come about here in the last half of the last sheet. For the first 7.5 sheets of paper, there weren't really perceived any such conflicts. I mean, if we go back to the Egyptians, where they were trying to figure out how to heal people, up to the Greeks that were doing their rational inquiry in the museum, the Temple to the Muses, up into the medieval scholastic university system. And all that time, the rational inquiry was done in the context of religion. Now, I'm not saying that there isn't conflict necessarily between science and religion, because nowadays in America we have like the culture wars, and like down south they debate over whether we should be teaching biblical creationism or evolution in the public schools. But I do want to point out just how recent in time that event is, how currently that happened, and how contemporary an issue that is. All right, thank you very much.